In this example, we want to determine if a series converges using the ratio test, one of our methods that we have for determining convergence. So in this case, we're looking at the series from n is 2 to infinity of n factorial cubed divided by 3n factorial. And if we look at this, since we see factorials in the expression, we want to try to use the ratio test to figure this out. So let's set up the ratio that we need to do the ratio test. So looking at the limit as n goes to infinity of the n plus first term divided by the nth term, which in our case here is limit n goes to infinity. an plus 1 will be n plus 1 factorial cubed divided by 3n plus 1 all factorial. And then divided by the nth term, which is n factorial cubed over 3n factorial. Now I want to use my rules for dealing with factorials in order to simplify this. So what I know, as an aside here, is that n plus 1 factorial is n plus 1 and then times n factorial, and that 3n plus 1, all factorial, is distributing to 3n plus 3 factorial, which is 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. The point here is now things will cancel, whereas this n factorial will cancel with the n factorials here, and this 3n factorial will cancel this guy here. So if I plug these two things into my expression here, what I'm going to see is the limit as n goes to infinity of n plus 1 cubed times n factorial cubed, because I'm plugging this here into the cubed here, so both factors get cubed, divided by 3n plus 3, 3n plus 2, 3n plus 1 times 3n factorial, and all divided by n factorial cubed over 3n factorial. The n factorial cubes will cancel, the 3n factorials will cancel, so then I am left with the limit as n goes to infinity of n plus 1 cubed over 3n plus 3, 3n plus 2, 3n plus 1. Now if we were to expand out the top and bottom, the highest power I see on top is an n cubed in the first term, and the bottom I will see a 27n cubed, so I'll see 3n times 3n times 3n. So this limit here is going to be a 1 over 27, which is in fact less than 1, so therefore this series converges by the ratio test. It converges absolutely because all terms are positive, but the important thing is that it converges by the ratio test. That's how you would set up and solve this example of a series analyzing its convergence by the ratio test.